All right, for section 4, the terms that we're going to use on the left-hand side here to where you get the 4s. Those are the vocabulary words in section 4. And there are quite a few of them today. First one is array. Array is defined as part of a line that has one endpoint and it extends infinitely in one direction. It's named using the endpoint and another point on the array. So here's a picture of array. We've got our arrow on one end, endpoint on the other. Are we ready? Okay. Array. Part of a line that has one endpoint, extends infinitely in one direction. In this picture over here, starts at point A, it extends through point B, and you got the arrow on the end, which means it keeps going forever and ever. We would call that ray AB. And to name that ray, you start with the endpoint, and then the second point is the one that it goes through. So this would be called ray AB. The symbol for array is a bar with one arrow going to the right. Yep.
Okay, so if you were to take away point A on the top right, what would you name it? Or do you have to have 2 points to make it array?
You have to have 2 points to name array. Yep, that's a good question. But you do have to have 2 points to name array. So your symbol for array will always have the arrow pointing to the right, even if your array points to the left, like down here in the second picture. This array starts at point C, it extends through points B and A. When we go to name that array, we could either call it ray CB or ray CA. Doesn't matter which one, they're both the same thing. But your arrow will point to the right on your symbol all the time. Even if you're in your picture, the arrow goes to the left. So you always start with naming your array with the endpoint, and then one of the other points that it goes through. That is array. Any questions with array? Okay. Opposite rays are when you put 2 rays together. And the definition is 2 collinear rays that have the same endpoint. So we've got 2 rays here that meet at point B. You have ray BA going off to the left, ray BC going to the right. Those 2 form a straight line, which makes them opposite rays. Say BA, ray BA, and ray BC are opposite rays. Opposite rays, we'll run into that a little bit. We don't use that a ton, but every once in a while you see that one. Any questions with opposite rays? Yep. Opposite rays and a line are the same thing. So yes, you could call it a line, you could call it opposite rays, that's the same thing. So you would be correct either way, whichever way. All right, let's go down to an angle. You guys have worked with angles before. We'll start with the definition. An angle is formed by 2 non-collinear rays. Remember what non-collinear means. That means they don't form a straight line. So we're going to have 2 non-collinear rays that have a common endpoint. Here's a picture over here on the right. Ray BA is kind of heading up to the right. Ray BC is kind of heading down to the right. Those 2 connect at point B. That makes them an angle. That figure form there is called an angle. Now there's some parts of the angle you need to know. The rays are called the sides. So in this picture over here, ray BA would be a side, ray BC would be a side. And the common endpoint where they meet here in the middle is called a vertex. And that's a word you'll see a bunch of this year, vertex. So the point where they meet is a vertex. When we're naming an angle, there's a few different ways to do it. One way is to name it using 3 letters. When you name it using 3 letters, the vertex has to be the second of the 3 points. So up here, I could call this angle ABC, or I could call it angle CBA. Either way, the B has to be in the middle, which you see right here. Now, the other way to name this, you can name an angle using a single letter, only when there's exactly one angle located at that vertex. So up here on this top picture, I could call this angle B because there's no other angle coming out of point B. But down here on the bottom picture, you've got several angles. You've got a couple of angles here coming out of point B. So I couldn't call this one angle B. because it has more than one angle coming out of B. But if there's just one angle coming out of B, you could call it angle B. So there's your second way to name it. And then sometimes they'll put a little number on the inside of it. The book does this a lot. They'll put a number on the inside of the angle. If they do that, you can call it angle 2. Okay, but on all those, B is your vertex. Okay, and if you come down here, this one, you've got a few different angles with B as the vertex. Angle 2 has B as a vertex. Angle 3 has B as a vertex. And then there's also the big angle. Angle ABD would also have B as a vertex. So a lot of stuff going on in that second picture. Any questions with the angle? How many people have seen angle before? Okay, nothing new there. That's good. If they ask you to find the measure of an angle, they want to know how many degrees it is. We measure angles in degrees. So when we got an angle over here, like this angle ABC, if they put a number with degrees behind it, that's how many degrees the angle is. So the measure of angle ABC would be 43 degrees. The little m in front of the angle symbol, that means measure. So read this as the measure of angle ABC equals 43. In your picture over here, you got 43 degrees here. This angle ABC, it's going to be 43 degrees. Now that ties right into congruent angles. Congruent angles, we've already done congruent segments this year. Congruent segments have the same length. Congruent angles are going to have the same measure. So if you have a couple of different angles with the same measure, we can say they're congruent to each other. In this picture over here, we have two angles that are 21 degrees. Angle ABC is 21, angle MNP is 21. So we can come up here and say that those two angles are congruent to each other. Once again, the symbol for congruent is the equal sign with the little squiggly line above it. Let's see. That's the first way you can know the angles are congruent. They give you the same degree measurements on there. Now the book will also do another way. It will have another way of showing you that angles are congruent to each other. If you come down to these next two, if you notice in the corner there's a little arc in the corner of each of these angles. We call that a congruence mark again. If they put the little arc in the corner, if two angles have the same number of arcs, that means those angles are congruent to each other. The book will do this a lot. They'll put the little arc in there to show you that the angles are congruent. So just realize that will show up quite a bit. If they have the same number of arcs in the corner by the vertex, that means they are congruent to each other. All right, any questions with congruent angles? All right, last part should be something you've seen before. Right angle is going to be a 90-degree angle. To show it's a 90-degree angle, we can either put 90 degrees in the corner or they can put the little box in the corner. They will do it both ways. Probably you'll see the box more often than anything. But that's a right angle. It's going to be exactly 90 degrees. If you're less than 90 degrees, that's going to be called an acute angle. Here's a picture over here of an acute angle. That angle is less than 90. And if you go to obtuse angle is going to be greater than 90 degrees. That means it's opening up more than 90 degrees. This angle over here, that picture is 90 or is a obtuse angle. How many people have heard right, acute, and obtuse before? Okay, nothing new there. Last definition for today. If you remember back to when we did segments, we talked about a segment bisector. A segment bisector split a segment in half. An angle bisector is going to do the same thing. It's going to be a line, ray, or segment that divides the angle into two congruent angles. So if you come over to our picture here, this big angle ABC, you've got a ray BM going right through the middle of that angle, splits it into two 30-degree angles. So we could say that ray BM is an angle bisector. It's splitting that angle in half. Yep.
Do they have to split it into like congruent?
It has to split them into congruent angles. Yep. So an angle bisector will always split it right down the middle. Those two parts will have to be congruent. Let's see, did I miss anything here? All right. Any questions with the angle bisector? Okay, it's going quicker than I thought. Now, for your actual written notes, you can take out your paper now for that. I've got a little bit to do for notes, not a whole lot. And like always, let's get your date on here. Today is Monday, September 13th. And basically, all I gotta do is show you a few examples here. I think there's just 2 or 3 of them. So, all right, let's call this letter A. We'll start with the picture on letter A. We're gonna start with a straight line. And on that straight line, we're gonna put some points. We got K here, we've got J in the middle, and we got P on the end. Now, this is something we haven't talked about yet, but the book is going to assume you already know this because you probably already do. Does anybody know what the measure of a straight line is? If you put that on a protractor, how many degrees a straight line is? 180. So anytime you see a straight line, take 180 degrees. Okay, so that's going to be 180 degrees. We're going to add to the picture here a little bit. Going straight up from there, we're going to have a ray. Point M on it. And we're going to make a right angle. Just put a little box in the corner of that. Once again, that little box reminds you that's a right angle, 90 degrees. We're going to put another ray coming out of J. It's going to come out this way through point N. One last ray coming this way through point L. Then there's 2 other things we're going to add to the picture. They're going to tell us that angle LJK is 80 degrees. And over on the other side, angle NJP is going to be 20 degrees. And then for our directions, they're going to tell us to classify and find the measure of each angle. Then they're going to give us a few angles. They want us to find out what kind of angles they are, what their measure is. Let's start with angle 1. They're going to ask us to find angle MJP. And they want 2 parts to our answer here. They want us to classify, which means they want us to name it. They want us to tell if it's right, acute, or obtuse. And then we're going to find the measure of each angle, which is how many degrees it is. Let's start with the degrees. Angle MJP. If you look at angle MJP, that's going from M to J to P. You got a little box in the corner of angle MJP. What's that box mean? It's 90 degrees. So its measure would be 90 degrees, which makes it what kind of an angle?
Right.
That's a right angle. All right, a little more complicated as we go. Let's do angle LJP. You look at angle LJP, that starts out here at L, comes down to point J, extends through point P. We're talking about all of this stuff on the right. There's 2 different ways we could get our answer here. I'm gonna show you the longer way first, because I think most of you probably see it this way. Let's go back to that angle we just talked about. Angle MJP is 90 degrees. If this little angle NJP is 20, what does that leave you for angle MJN? 70. How'd you get 70?
90 minus 20.
90 minus 20. This whole angle is 90. This little part here is 20. Take 90 minus 20, that leaves you 70 degrees for the rest of the angle. And now let's do the same thing on the left-hand side. Angle MJK, that's also going straight up and down. It doesn't have a box next to it, but if you wanted to, you could make a box there, because we know that this straight line is how many degrees? 180. So if this is 90, that means this part has to be 90. Because 90 plus 90 is 180. Now, the part we're missing right now is angle MJL. If MJK is 90 and LJK is 80, what's that leave you for this little angle?
10.
That's going to be 10. So now if I want to find the measure of angle LJP, starts at L, comes down here to point J, extends through point P, that's collecting the 10-degree angle, the 70-degree angle, and the 90-degree angle. What's 10 plus 70 plus 90? That's 100 degrees. Now, before I go any further, is there anybody who does not see where we got 100 degrees for LJ? Okay, 100 degrees, is that right, acute or obtuse? That's obtuse. All right, one more together. Angle MJP. Now that everything's marked for us up here, it's pretty easy. If you look at angle NJP, inside of angle NJP, you've got 20 degrees. That means it's a 20-degree angle. And if it's 20 degrees, is that right, acute or obtuse? Maybe do one all by yourself. Does anybody need to see more before we do one by ourselves? Okay, for number 4, I want you to try this one all by yourself. I want you to find the measure of angle LJN and tell whether it's right, acute, or obtuse. Just go ahead and do it right there on your paper. Okay, a lot of these are looking good. Anybody want more time to finish this one? Okay, we want angle LJN. That's going to start at L, come down to J, extend through N. That's that angle right there. That's the 10 and the 70 put together. 10 plus 70 is 80 degrees. 80 degrees is less than 90, so that's 20. Any questions on how we got 80 and acute for that? Okay. Does anybody need to see another one? We're picking angles out of the picture. Good with that? Okay. The last thing we're going to do is put a little algebra in here. So this one, letter B. Same thing, we'll start with the picture. This time, your straight up and down line. This is going to be your 180-degree line. This is, you want to call it an angle, angle MKJ. This picture, we're not going to have a right angle. We're going to have a ray that kind of comes out in an angle here through point N. Another ray that comes out through point L. Now, in this picture, instead of putting things into the actual picture, they're going to give you some directions. They're going to tell us that ray KN bisects angle JKL. That will be given to you in the directions. And then here's where the algebra comes in. They're going to tell us that the measure of angle JKN is 8x minus 13. Measure of angle NKL is going to be 6x plus 11. And then finished off, they want us to find the measure of angle JKN. Now, as you're putting this together, you may look at this right away and go, the measure of angle JKN, they gave me that already, it's 8x minus 13. 8x minus 13 is not the answer we want. What we want, when they ask for the measure of an angle, they want to know how many degrees it is. 8x minus 13 is not a number of degrees. We want to put a number in for x to figure out how many degrees it is. So that's what we're doing on this one. We're going to solve for x, and that will tell us how many degrees angle JKN is. Okay, let's start from the top. Ray KN bisects the angle. Who remembers what it means if you bisect something? I'll call you Audrey, that's not right. Yeah, Avery. Okay, and the ray is going to go through the middle of the angle, split it into two congruent angles. So angle JKL is the one being bisected. Let's go to our picture here. Here's angle JKL. JKL is being split in half by ray KN. What that means is these two angles are going to be congruent. To show that they're congruent, I'm going to put the little arcs in the corner. That right there shows me that ray KN bisects angle JKL. So remember, bisects means it cuts in half. JKL in this picture is getting split into two congruent angles. All right, did we lose anybody there? Okay, once you got that, now you're in business here. The measure of angle JKN is 8x minus 13. I'm going to put that in the picture. Here's JKN, it's 8x minus 13. The other angle they give us is NKL is 6x plus 11. NKL is this angle. And what do we know about those two angles we just wrote in there? The 6x plus 11 and the 8x minus 13. Avery, what do you think? They're congruent. You get the little congruence marks here. That means these are congruent. If those two are congruent, that means they're equal to each other. So 6x plus 11 would equal 8x minus 13. We're going to do a lot of this in geometry this year. They're going to give you two angles that are congruent. They give you algebra to go with it. You're going to put those equal to each other. Once you're to here, you just do the algebra. If you subtract 6x from the 8x, you get 2x here. And I'm going to add 13 to this side, which gives me 24. And if we divide by 2, x will be 12. X is 12. Am I finished? No, we found x. What do they want us to find? They want the measure of angle JKN. So I have to take this 12 and I have to put it back into JKN. Well, if I go up here to my picture, JKN is 8x minus 13. I'm going to put that 12 in there. And then I can find the measure of angle JKN. It's going to be 8 times x, which we just found to be 12, minus 13. Anybody do it in their head? What's 8 times 12? 96. 96 minus 13 is measure of angle JKN is going to be 83. If you want to put the degrees on there, you can. If you just write 83, I would understand what that means. That's fine. Either way is good. That's how it's gonna look if they throw a little algebra in there. Any questions with that one first of all? Okay, so maybe you see another one of these. How many think it's easy? Okay. Now, there is an assignment that goes with this. The worksheets 1, 4, and 1, 5 go together. We can either start it today or we can leave it for tomorrow, for next time you come to class. Let's see what it looks like. I think we should save it for tomorrow. What do you guys think? Yeah. Probably is going to work better if we do that. Let's do that. We'll save that one for the next time you come to class. Okay, anybody need to see more of this? Okay, that's it for today then.